Lewis structures are a very useful way of representing covalent molecules in two dimensions. In a Lewis structure, a bonding pair of electrons is represented as a line, and a lone pair of electrons is represented as two dots. In this video, we're going to go through the steps you should take to draw simple Lewis structures, going through a few specific examples. You can print out the worksheet which is attached to this video to help you go through the examples as we go along. The first Lewis structure that we're going to draw is hydrogen fluoride. And the first step in drawing a Lewis structure is always to count the total number of valence electrons in the molecule. Remember that valence electrons are those in the outermost orbitals. For the first two rows of the periodic table, an easy way to calculate the number of valence electrons for each element is to count back to the last noble gas. So for fluorine, we can count 1, 2, 3, 4, 5, 6, 7, and that tells us that fluorine has 7 valence electrons. For carbon, we can count back 1, 2, 3, 4. That tells us that carbon has 4 valence electrons. The first Lewis structure that we're going to draw is hydrogen fluoride. And the first step in drawing a Lewis structure is always to count the total number of valence electrons in the molecule. Remember that valence electrons are those in the outermost orbitals. So an easy way to count valence electrons is to count back on the periodic table to the previous noble gas. So here for fluorine, we count back 1, 2, 3, 4, 5, 6, 7. That tells us that fluorine has 7 valence electrons. We also know, looking at the periodic table, that hydrogen has 1 valence electron. So our hydrogen gives us 1, our fluorine gives us 7. That gives us a total of 8 valence electrons, and we need to keep track of this in our final Lewis structure. The next step in drawing a Lewis structure is to draw a single bond between the atoms. Here we've got our hydrogen and our fluorine, and we've drawn a single bond between the two. The next step is to count how many electrons we have left and assign them as lone pairs to fill the valence shells of each of the atoms. Now, just a reminder of what a filled valence shell will look like. In this video, we're going to be considering hydrogen. Its filled valence shell will be 2 electrons. In the case of all of the other elements that we are considering today, they will have a filled valence shell containing 8 electrons. This is true because we're only going to be considering elements in the second row of the periodic table, and for them, their filled valence shell is 8. This sometimes is called the octet rule. There are many other elements which can exceed the octet rule, but they won't be considered in this video. So we need to count how many electrons we have left over. We know that we need to account for 8 electrons altogether, and in this structure at the moment, we've only accounted for 2 electrons in this bond. So we've got 6 more electrons we need to account for. If we have a look at our 2 atoms, hydrogen already has 2 electrons associated with it. It has both of these electrons in this bond. It does not need any more electrons. Fluorine has 2 electrons associated with it. Again, the 2 electrons in this bond. So it needs 6 electrons. Luckily, we have 6 electrons left over, so we can assign them as 3 lone pairs to the fluorine. Let's just check that we've got the right structure by adding up the total number of electrons in our structure. We've got 1, 2, 3, 4, 5, 6, 7, 8. And that corresponds to the 8 valence electrons we need for this molecule. So this is the correct Lewis structure for HF. The next example that we're going to look at is O2. The first thing we need to do is to count the number of valence electrons in the molecule. Here we can look at oxygen on the periodic table and count back 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons. So each of the oxygens has 6 valence electrons. That gives us a total of 12 valence electrons that we need to account for. So our first step is to draw a single bond between the atoms. Here we have our single bond. The next step is to count how many electrons are left and assign them as lone pairs. We've accounted for 2 electrons in this structure. We need 12 electrons altogether, so we have 10 electrons left over. Since we have a nice symmetric molecule, let's just assign 5 electrons to each oxygen. Okay, let's count now how many electrons each oxygen has. This oxygen has 1, 2, 3, 4, 5, 6, 7. Remember, it has both electrons from the bonding pair. That's only 7. Oxygen needs 8 to fill its valence shell. So we need to go on to a fourth step in our steps for making a Lewis structure. The fourth step is if there are incomplete valence shells to form multiple bonds to complete these valence shells. What we can do is form a bond between these two lone electrons, and that will allow these to be shared between the oxygens. So let's make a double bond between our oxygens, assign the rest of our electrons, and here you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons altogether. We've still accounted for our 12 electrons, but let's have a look at how many electrons each oxygen has. This oxygen on the left has 1, 2, 3, 4, and then it has 1, 2, 3, 4 from the bonding pairs. So this is the Lewis structure for oxygen. The next example that we're going to look at is NF3. And again, we'll go through the steps in order. First, we need to count the total number of valence electrons. We have 5 valence electrons in nitrogen and 7 valence electrons for fluorine. That gives us a total of 26. Next, we need to draw simple single bonds between the atoms. So here nitrogen will be the central atom and it will be connected to all 3 fluorines. Next, we need to count how many electrons are left over. We've accounted for 6 electrons so far in our 3 bonds. We have to have 26 altogether, so we've got 20 electrons left over, still to assign. Now let's think about how many electrons each of our atoms needs. Our nitrogen currently is sharing 3 bonds. That means it already has 6 electrons in its valence shell. It only needs 2 more to form its 8. Each of the fluorines is only participating in a single bond. This means that they each need 6 more electrons. And you'll see that in assigning electrons in this way, we have assigned the remaining 20 electrons. Let's just check that that's correct by counting the total number of electrons. We'll count electron pairs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 electron pairs corresponds to 26 valence electrons. So this is the correct Lewis structure for NF3. Another example that we're going to look at is HCN. Here we count the total number of valence electrons. Hydrogen has 1, carbon has 4, nitrogen has 5. That gives us a total of 10. We need to have 10 electrons in our final Lewis structure. Let's draw single bonds between the atoms. In this case, carbon is our central atom. Let's count how many electrons we have left to assign. We've assigned 4 already in these bonds. We need 10, so we've got 6 left to assign. Now hydrogen already has its filled valence shell. Carbon already has 4 associated with it. It needs 4 more. Nitrogen, okay, so we've already used 4 of our 6. So we put the last 2 on nitrogen. But now how many electrons does nitrogen have in its valence shell? It only has 1, 2, 3, 4. That's not enough. That means we need to go on to step 4 and begin to form some multiple bonds. Let's try forming a double bond between the carbon and the nitrogen. This has used up 6 electrons, so we've got 4 more to assign. We will give 2 to our carbon. This carbon now has 8 electrons around it. We've got 2 left to give to the nitrogen. But this nitrogen only has 6 around it now. It still hasn't met the octet rule. Let's try and make another bond. Here now we'll have a triple bond between the carbon and the nitrogen. Now we've used up 1, 2, 3, 4, 8 electrons. We only have 2 more electrons. This carbon here, you'll see, already meets the octet rule, already has 8 electrons around it. So we'll put the remaining electron pair on this nitrogen. Now this nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Count how many electrons we have in the whole molecule. We've got 1, 2, 3, 4, 5 electron pairs. That corresponds to 10 valence electrons. So this is the Lewis structure of HCN. The final Lewis structure that we're going to draw is the Lewis structure for an anion. The important thing to remember in a charged molecule is that the charge will change the total number of electrons we need in our Lewis structure. So our first step is to count the number of valence electrons. Oxygen has 6, hydrogen has 1, but now we have an extra electron as our negative charge, so that will count as an electron. A positive charge will take away 1 electron from the total. So here this gives us a total of 8 electrons that we need to account for. First, we draw our bond between oxygen and hydrogen. That's accounted for 2 electrons. We need to account for 6 more. Let's arrange those 6 electrons on the oxygen. Now the oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. The hydrogen has 2, just as it wants. And in total we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. We often show the charge on a Lewis structure by drawing square brackets and showing the overall charge. In this case, we've got an overall charge of -1.